Now, let us discuss about data storage units. It is important to measure the data, how much it is. The standard units are required to measure the amount of data, whether stored in a digital system or whether it is being transmitted. So, data storage unit represents the size of data in various forms, whether files, whether storage media, whether memory. As we all know, computer understands only zeros and ones, and all the digital systems or electronic systems, they understand only zeros and ones. So, a 0 or a 1 is a bit, and it is the smallest unit of data in computing world. You combine bits, a combination of 4 bits is known as nibble. 8 bits combined is known as byte, and it is used to store a single character. In the same way, another very popular unit, well-known unit, is kilobyte. So, 1 kilobyte is equivalent to 1024 bytes, and 1 byte is 8 bits or 2 nibbles, or 0 or 1 is single, 1 digit or a bit. Megabyte is another popular data storage unit, and 1 megabyte is equal to 1024 kilobyte, this one. In the same way, gigabyte, GB, 1 gigabyte is equal to 1024 megabytes, and for representing huge or larger data, these units are now used. Then, most popular terms for data storage are terabytes, petabytes, exabytes, zettabytes, yottabytes, and they are all used for, measuring massive storage systems or massive data. This is again a summary of data storage. Bit represented by B, byte B, small b, capital B, kilobyte KB, megabyte MB, GB gigabyte, TB terabyte, PB petabyte, EB exabyte, ZB zettabyte, YB yottabyte. All the data in computers or any digital system is represented as a combination of zeros and ones. So, even when these data are represented using some encoding schemes, a slight change of 1 bit will change the entire meaning of that data. So, it is important that when the data is stored onto a system, it should not make any error. That medium, plus when these data are transmitted or transferred from one place to another place, whatever data is being transmitted, it should remain pure. There should not be change in it. So, in case there are some errors which are bound to happen, which is natural for various reasons. So, there must be certain way to identify what happened with that data. So, it is important to detect the errors, and once it is detected, it is important to correct it, right? So, error detection and corrections are very important concept in data representation. and there are various techniques for this purpose. One is parity check or parity bit technique. It is a single bit technique which is wherein a single bit is added to data to check the errors in the data. In the same way, checksums are another way, and the third one is CRC, which is very popular and very safe. CRC stands for cyclic redundancy check. It is another technique or scheme, and it is very, very essential for maintaining the integrity, means the purity of data in communication systems, in storage systems, and in distributed computing environment. So, distributed systems. Transmission of data. Nowadays, we talk of network all the time. Network of what? Computing devices. Network of what? Digital devices. So, they can be connected, whether wired or in a wireless environment, but they can be connected. And whenever they are connected, they can communicate with each other, right? So, while data is transmitted, some medium is required from one place, its movement from one place to another place. So, that movement is known as transmission, that can happen in wired medium as well as wireless medium. This transmission of data is done by transfer of bits, and these bits can be transferred in two different ways. Say for example, if we have to send 8 bits, we will begin with sending first bit, then second, then third, then 4, 5, 6, 7, 8. One by one, bit by bit transmission. If that is the case, it is known as serial transmission. One transmission medium and it is carrying bits one by one. We can send the data, same 8-bit data all at once, but not on a single channel. We will need 8 different channels and we can send it at once. So, that will be known as parallel transmission. So, here we have concepts of serial as well as parallel transmissions. For parallel transmissions, the linking cost will be high. Various protocols are a set of rules of communication. Most popular protocols are TCP/IP, Transmission Control Protocol, Internet Protocol, which is used in Internet. We all at least know this protocol, HTTP or HTTPS, Hypertext Transfer Protocol or Hyper Text Transfer Protocol with security. So, secured hypertext transfer protocol. Then FTP is another important protocol, which is file transfer protocol, and there are many such protocols. These are some examples. Next important aspect is encryption. When data is stored or transmitted from one place to another place, if any unauthorized person can access it, its confidentiality will be disturbed, right? Its privacy will be disturbed. So, it is important that only authorized users or authorized receivers or person could use or access this data. There are methods. Using those methods, we can safeguard these data. Data encryption is one such way wherein what we do, we scramble the data which is being sent, and that data is known as plain text, which is being transferred or which is to be sent. It is scrambled in such a way that no meaningful conclusion could be drawn from it. How it is done? It is done using one key. And what other thing is required? One algorithm which will do it. So based on the key, that algorithm which will encrypt it or scramble it, that algorithm will be known as encryption algorithm, or the system will be known as encryption system. It will scramble and it is sent. When the receiver receives it, he will also not be able to understand it until unless he has that key. Plus what? A system which will reverse the process of encryption. And that reverse process of encryption is known as decryption. So another system or algorithm which will be known as decryption algorithm with the key which is used for decrypting it will result in the plain text which is meaningful to the receiver now. There are two types of encryptions possible. One is known as symmetric encryption. Symmetric means the same key is used for encryption as well as decryption purpose. So, suppose I have to send a plain text to Mohan, who is the receiver, I am sender. I will choose a key and use one algorithm. Using this key and algorithm, I'll encrypt this plain text and send it. Mohan would need a decryption algorithm plus a key. In case of symmetric encryption, same key will be used for decryption as well. So, I will have to give this key to Mohan or tell this key to Mohan. Using this key and decryption algorithm, Mohan will be able to decrypt it and he will get the plain text. Second one is asymmetric encryption. It does the same thing, encryption and decryption, but the concept of keys are different here. Asymmetric means one key for encryption, another key for decryption, which is different from the encryption key. So, if I am the sender, I have to send something to a receiver, I need to have two keys. One key for encryption and one key for decryption. In the same way, the receiver need to have two keys. One key for encryption and one key for decryption. So, if I have to send something P to R, what I will do? I will encrypt it and send it. Now, once it is encrypted with this key, it can only be decrypted with this key, right? In the same way, if it is encrypted with this key, it will only be decrypted with another key. So, I will encrypt it and with, say for example, this key, and I'll share this key with R. Using this key, it will be decrypted. So, it will be known to R in advance. So, normally what happens, this decryption key, both sender and receivers, they make it public, right? And they encrypt it with their key and send it to the other, and using decryption key, the receiver receives it. So, important point here is to note that how to trust this key, whether it is symmetric key encryption or whether to asymmetric key encryption, it's a challenge. And for this, various mechanisms are there, various infrastructures are there. I leave it to the learners to learn about it. Next is data security in representation. Secure data representation techniques are very, very important. What is this secure data representation technique? These are the methods and properties for organizing, for storing and transmitting the data to ensure that its confidentiality is not disturbed, its integrity is not disturbed, its accessibility is not disturbed. There are many secure data representation techniques. Let us look into it. One of them is data encryption, which we have just discussed. Another one is data masking. What is data masking? It is a method of obfuscating sensitive data by replacing it with fictional or masked data. The key features are static and dynamic masking, and it is used in testing environment. Tokenization is another technique which replaces sensitive data with token linked to original data securely. Data compression, we have already discussed about it. Hashing is another such technique wherein plain text is converted to a fixed length text using some algorithm which is known as hash algorithm or hash function. In the same way, homomorphic encryption is another technique. Secure multi-party computation, SMPC, is another technique which divides data among parties to preserve privacy during computation. Another very important term is steganography, which hides data within other files like image files, in audio files, in video files. These are very popular ways of hiding information. Access control representation, data splitting and distribution, data marking is another very important technique which embeds patterns into data to trace ownership or to trace leaks of data. Blockchain, which is becoming very popular, which uses decentralized ledgers for immutable and secure data representation. Now, let us see the recent developments in data representation. Big data, and this term is in use these days. Big, as the name implies, big means huge, large in size. So, the data or data set that is too large in size and which are difficult for the traditional data processing tools to handle, which are difficult for traditional data processing tool to analyze. That kind of data set or that kind of data is called big data. The major characteristics of big data is volume. It is huge, so it is large in volume. It is of different types. So, variety is another important characteristics. So, this big data can be structured, it can be semi-structured, it can be unstructured data. Another important characteristic is velocity. The rapid generation of data. These days, IoTs are being used. We are using social medias and all. Within seconds, terabytes of data within minutes every day of such huge data are being produced. Veracity is another characteristic of big data. Challenges that big data pose is storage. It requires distributed file system. Processing is another important challenge. It needs parallel processing frameworks. And good thing is that there are technologies to handle it. To handle big data, A number of technologies are available. Some of them are Apache Hadoop, Apache Spark, Apache Cassandra, Apache Hive, Apache Kafka, Apache Flume. Next important concept is data in cloud computing. What is cloud? The delivery of computing resources, whether storage, whether servers, whether softwares, through internet is called cloud computing. Instead of having your own system, as we discussed earlier, you can look for the storage, servers, softwares and other such things. If you have internet connections, good internet connections, you can access remote servers to get these resources, right, in the type of services. So, various variations of cloud computings are available: public, private and hybrid clouds. The major benefits that they are available on demand. They are scalable, so you can scale up or scale down depending upon your need. It is good for cost saving, so you can save your cost, and it is for remote accessibility. The most popular models of cloud computing services are infrastructure as a service, platform as a service, software as a service. Infrastructure as a service offers compute and storage services. For example, AWS, for example, Microsoft Azure. Platform as a service offers a develop and deploy environment to build cloud apps. For example, Salesforce, for example, Windows Azure, for example, Google App Engine. They are very popular and it is very much known. SaaS, software as a service. It delivers apps as a service. For example, we make use of Dropbox, we make use of Cisco WebEx, we make use of Microsoft Office 365. And there are many providers of such services. The popular ones are Microsoft, Amazon, Google, and we are all making use of these services. So let us summarize what we learned. We learned about binary and number systems. We learned about data representation, be it textual or audio or image and video data. We also discussed about important concepts like data compressions, like storage units, data structures, file formats. We discussed about security and we discussed about some recent developments in data representation. So, here we stop. In the next lecture, we will be discussing some new topics. Thank you very much.